Hello guys and welcome back. Today we bring you a tentative analysis of the Big Bang Theory. You all know that it took quite a bit more than 7 days to create the universe as we know it today. Our universe was born about 13.7 billion years ago in a massive expansion that blew space up like a gigantic balloon. That, in a nutshell, is the Big Bang Theory, which virtually all cosmologists and theoretical physicists endorse. The evidence supporting the idea is extensive and convincing. We know, for example, that the universe is still expanding even now at an ever-accelerating rate. Scientists have also discovered the predicted thermal imprint of the Big Bang, the universe-pervading cosmic microwave background radiation, and we don't see any objects obviously older than 13.7 billion years, suggesting that our universe came into being around that time. All of these things put the Big Bang on an extremely solid foundation, said astrophysicist Alex Filippenko of the University of California, Berkeley. The Big Bang is an enormously successful theory. So we ask today, what does this theory teach us? What really happened at the birth of our universe, and how did it take the shape we observe today? Let's start from the beginning. Traditional Big Bang theory posits that our universe began with a singularity, a point of infinite density and temperature whose nature is difficult for our minds to grasp. However, this may not accurately reflect reality. Researchers say because the singularity idea is based on Einstein's theory of general relativity. The problem is, there is no reason whatsoever to believe general relativity in that regime, said Sean Carroll, a theoretical physicist at Caltech. It's going to be wrong because it doesn't take into account quantum mechanics. All quantum mechanics is certainly going to be important once you get to that place in the history of the universe. So the very beginning of the universe remains pretty murky. Scientists think they can pick the story up at about 10 to the minus 36 seconds, 1 trillionth of a trillionth of a trillionth of a second after the Big Bang. At that point, they believe the universe underwent an extremely brief and dramatic period of inflation, expanding faster than the speed of light. It doubled in size perhaps 100 times or more, all within the span of a few tiny fractions of a second. Inflation may seem to violate the theory of special relativity, but that's not the case, scientists say. Special relativity holds that no information or matter can be carried between 2 points in space faster than the speed of light, but inflation was an expansion of space itself. Inflation was the bang of the Big Bang, Filippenko told Space.com. Before inflation, there was just a little bit of stuff, quite possibly expanding just a little bit. We needed something like inflation to make the universe big. This rapidly expanding universe was pretty much empty of matter, but it harbored huge amounts of dark energy, the theory goes. Dark energy is the mysterious force that scientists think is driving the universe's current acceleration and expansion. During inflation, dark energy made the universe smooth out and accelerate, but it didn't stick around for long. It was just temporary dark energy. Next, we look at the big bounce. Most cosmologists regard inflation as the leading theory for explaining the universe's characteristics, specifically why it's relatively flat and homogeneous with roughly the same amount of stuff spread out equally in all directions. Various lines of evidence point toward inflation being a reality, said theoretical physicist Andy Albrecht. They all hang together pretty nicely with the inflationary picture, said Albrecht. However, inflation is not the only idea out there that tries to explain the universe's structure. Theorists have come up with another one called the cyclic model, which is based on an earlier concept called the ekpyrotic universe. This idea holds that our universe didn't emerge from a single point or anything like it. Rather, it bounced into expansion at a much more sedate pace than the inflation theory predicts. The beginning of our universe would have been nice and finite, said Bert Ovroth of the University of Pennsylvania. The cyclic model posits that our universe consists of 11 dimensions, only 4 of which we can observe. There could be other brains lurking out there in 11-dimensional space, the idea goes, A collision between two brains could have jolted the universe from contraction to expansion, spurring the Big Bang we see evidence of today. The next we are going to look at is the universe we know takes shape. But first, how did our universe spring up out of nothing? Cosmologists suspect that the four forces that rule the universe, gravity, electromagnetism, and the weak and strong nuclear forces, were unified into a single force at the universe's birth, squashed together because of the extreme temperature and densities involved. But things changed as the universe expanded and cooled. Around the time of inflation, the strong force slightly separated out, and by about 10 trillionths of a second after the Big Bang, the electromagnetic and weak forces became distinct too. Just after inflation, the universe was likely filled with a hot, dense plasma, but by around 1 microsecond or so, it had cooled enough to allow the first protons and neutrons to form, researchers think. In the first 3 minutes after the Big Bang, these protons and neutrons began fusing together, forming deuterium. Deuterium atoms then joined up with each other, forming helium-4. Let's look at the recombination stage, whereby the universe became transparent. These newly created atoms were all positively charged as the universe was still too hot to favor the capture of electrons. But that changed about 380,000 years after the Big Bang in an epoch known as recombination. Hydrogen and helium ions began snagging electrons, forming electrically neutral atoms. Light scatters significantly off free electrons and protons, but much less so off neutral atoms. So photons were now much more free to cruise through the universe. Recombination dramatically changed the look of the universe. It had been an opaque fog, and now it became transparent. The cosmic microwave background radiation we observe today dates from this era. But still, the universe was pretty dark for a long time after recombination, only truly lighting up when the first stars began shining about 3 million years after the Big Bang. They helped undo much of what recombination had accomplished. These early stars and perhaps some of other mysterious sources threw off enough radiation to split most of the universe's hydrogen back into its constituent protons and electrons. This process, known as reionization, seems to have run its course by around 1 billion years after the Big Bang. The universe is not opaque today as it was before recombination because it has expanded so much. The universe's matter is very dilute and photon scattering interactions are thus relatively rare, scientists say. Over time, stars gravitated together to form galaxies, leading to more and more large-scale structure in the universe. Planets coalesced around some newly forming stars, including our own sun, and 3.8 billion years ago, life took root on Earth. And today we look also before the Big Bang, what happened. While much about the universe's first moment remains speculative, the question of what preceded the Big Bang is even more mysterious and hard to tackle. For starters, the question itself may be nonsensical. If the universe came from nothing, as some theories believe, the Big Bang marks the instant when time itself began. In that case, there will be no such thing as before, Carroll said. But some conception of the universe's birth can propose possible answers. The cyclic model, for example, suggests that a contracting universe preceded our expanding one. Carroll as well can imagine something existing before the Big Bang. It could just be empty space that existed before a Big Bang happened. Then some quantum fluctuations gave birth to a universe like ours. He said, you can imagine a little bubble of space pinching off through a fluctuation and being filled with just a little tiny dollop of energy, which can then grow into the universe what we see through inflation. I think time in our universe started with the Big Bang, but I think we were a fluctuation from a predecessor, a mother universe. What an expository narrative, documentary, and research. Whatever you have to say concerning this, drop your comment in the comment section and please don't forget to subscribe to this channel. Thank you very much.